Okay, so we're going to look at frequency distributions and frequency tables. Okay, this is something that you would have encountered before, that you maybe would have seen even like in probability when doing kind of tallies and keeping track of things like that and kind of looking at sample spaces. You would have run into this sort of idea. So we're looking at maybe applying some of our statistical knowledge now to these representations or these summaries of data. So a frequency distribution or frequency table, as I said, it's a method of summarizing a data set, and usually we'd use it for kind of slightly larger data sets. And what it does is it avoids us maybe having to write out every possible data point, but rather we just list the frequency of each data point, so how many times it occurs. So if I had a situation where, say, I have four letters A, B, C, and D, and their frequencies are like 4322. What that really means is that my actual data set is like A, B, 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 C, C, D, D. Like that's my actual data set, but this table is much clearer. It lets me see straight away there are four A's, there are two C's, and I'm able to do some kind of actual calculations around that much easier than just listing out the numbers. So it's a way of summarizing it, but making it more accessible for calculations. Within our frequency tables, we can apply our calculations of average, of mean, median, and mode. Mode, fairly easy to see. Again, you just look at the one that is most frequent, the one that's there the most. So whichever one is the largest frequency means that that data point appears most often in the data set. So thinking back to that example here, that's going to be A. I said there were four A's, it's there the most, and if we look at when it's written out fully, it is indeed there the most. The median would be the category or the value in which the middle value lies. So if I'm listing out my data set there, even in this case where I've used numbers, there is, I suppose, technically a middle value. There's not always an awful lot I can do with it, but because this is basically looking at kind of categories, we're just looking at kind of where is this middle value, where is the middle person, where is the middle thing in this set of data. And we can use that same trick that we had before, where we add 1 to the number of data points and divide it all by 2, and we look at the frequencies until we've included enough people are found where that middle one would be, and we give them the category or the relevant category or value as our answer. To find the mean, we take each data point and multiply it by its frequency. So for the example that I've given here, I actually couldn't really calculate a mean because you can't have a mean of categories like that. But if I have numbers, we can actually work to calculate a mean, and we'll see how that would work. But the reason we need to multiply by the frequency is because, as we've said here, the 4 means that there are 4 A's. So the frequency tells us how many times that number is repeated, and that obviously is going to have an impact on the mean value. The mean is where we add them all together, so we want to make sure that we're including enough of them. So let's apply all of this knowledge to an example here. So the following frequency distribution gives the ages of 18 students. So the fact that there's 18 students here is tied to the frequencies, because these are each of those 18 students grouped into their various ages. So the total of my frequency should match up with how many students I have. And that's important because that's going to be used in some of these calculations here. The first thing we're asked for is the modal age. So that's the mode. The mode is the one that's there the most. And here, that's going to be my 18 because it has the highest frequency. We're asked to calculate the median. That's the middle value. So the middle of 18, well, let's see, it's 18 plus 1 over 2, which is 19 over 2, which is 9.5. So the 9.5, we're looking between 9th and 10th value. Okay, we're looking between the 9th value and the 10th value. So what we need to do, slightly different to what we've had before, we need to go through these categories, looking at each of the frequencies until we've included or worked out where the 9th and 10th person are. So looking at, say, the first category here, if I only include this one, I have only included one person. Up to here, I've accounted for 3 people. Up to here, I've accounted for 4 people. Up to here, I've accounted for 7 people. Okay, if we go 4 more, we have accounted for 11 people. So given that up to here was 7, but up to here includes 11 people, that's going to mean that the 9th and 10th person are somewhere within this category. Okay, if we listed out all these values, as I said there in the example, so 12, 13, 13, 14, 15, 15, and so on and so forth, listing them all out as opposed to just the frequencies, the 9th and 10th value would be 16. Okay, so here the median value is 16. To calculate the mean, we have a tiny bit more work to do in our calculation for the mean, so I'm going to do it down here. To calculate the mean, we take the age and multiply it by its frequency. Then we take the next stage and we multiply it by its frequency. We take the next stage, we multiply it by its frequency, and so on and so forth. And we're adding all of these answers. And all of this then is going to be divided by how many data points are there, which is how many frequencies are there total, how many students were there. There were 18. So let's try and work out some of these. So 12 plus 26 plus 14 plus 45 plus 4, 64 plus 34 plus 90 all over 18. I'm going to get my calculator then to finish this one out. So 12 plus 26 plus 14 plus 45 plus 64 plus 34 plus 90 divided by 18, and that gives me an answer of not a full number but 15.83. Okay, so round about 16 if we were to round to the nearest whole number, which is interesting because that actually fits in nicely with our median value. So we look at one more example of the same sort of thing here, which is calculating the average value for Rohan here, who is scoring goals within a certain number of games, or points. So it's points within a certain number of games. So we have his number of points at the top and then the number of games within which he scored those points. So we need to look first of all and see, well, how many games were there altogether? Because that is essentially representing his frequencies in this case. So let me pull this one. So 4 plus 5 plus 4 plus 2 plus 3 plus 1 is 19. So we have 19 games in which he's played and has scored. Okay, they've given us an explanation there as well that the number of points, 12 appearing in 3 games, means in 3 games he scored 12 points. We're asked to work out his mean number of points to 2 decimal places. So we go through it like we just did in the last one. He had 0 points in 4 games. Okay, there's kind of no point in me including that one anyway, but I'll include it. 8 in 4 games, 10 points in 2 games, 12 points in 3 games, and 16 points in 1 game. And again, just to say that writing out all of this is just our way of kind of summarizing the data set that we have. So rather than writing out all the points, we're just including how many times does each appear, and then we're multiplying them to, again, save ourselves listing them all out and then adding them all up. It just kind of keeps things a little nicer for us. So this is going to be what? 62, 82, 82, 88, 118, 1, 2, 134. Okay, 134 over 19, and let's see what that gives us here. We're looking at about 7.052, I think was what it said there. Yeah, 7.0526. They said 2 decimal places, which would be 7.05 points. Now we might think for a second, does that seem reasonable? If we look here, 7 is maybe coming about because of all of this, kind of most of the data points around the center here. That is around about 13, which means that there's only 6 left in these higher brackets. So we are maybe expecting that average value to be somewhere near the lower end, or in that kind of middle to lower end, and even within that, most of the data points are within that 6 to 8 range. So 7 sounds like a reasonable number for us to get there. So that's kind of our general frequency distributions. We'll also look at grouped frequency distributions, so I'm going to do that in a second video, and we'll have similar calculations to look at there.